For this recording, I will show you how to do year 2009 semester 2 MST question 3b part 1. We are given a plane pass through the point 104 and the line T13T as in 3a. The first part of B is to find the normal to the plane, and this is what we are going to find. The normal to the plane. The plane passed through the point 104 and also the line T13T is contained on the plane. So first thing we have to understand is what is normal vector to the plane. What is this? Now, according to Howard Anton book in chapter 12 section 6, we have actually seen that for equation of a plane, the plane can be determined by a point and a normal vector. And what is a normal vector? A normal vector is actually a point, a vector perpendicular to the plane. Right? So a normal vector is actually a vector perpendicular to the plane, as you can see from here, and this vector is called the normal vector, the vector perpendicular to the plane, and this is called a normal vector, and is this vector here, n, with a plane. So we are going to find out a vector perpendicular to the plane, and that is called a normal vector. And in this case, in our problem, our plane contains the point 104 and the line T13T. In order to find the vector perpendicular to the plane, let's say this is the vector we want to find, we call it normal perpendicular to the plane. To do that, I need to help find some more points. One of them is find out what are the other points I can get. For example, I know the line TL is T13T. Now put T equal to 0. Let's say L0 is equal to what? T equal to 0. 1, 3 times 0 is 0, 0, 1, 0 is one point on the line. Let's call this point Q. Let's say this is a point Q here. Q is 0, 1, 0. Let's try another point. Let's say you can pick other point, other value of T. Let's say T equal to 1. Okay, L1 equal to what? 1, 1, T, 3 times 1 is 3. Let's call this point R. So R is this point. 1, 1, 3. So in this case, I have a 3 point on the plane now. Now given this 3 point on the plane, I can form vector PQ and vector PR. So let's try to figure out what is vector PQ and PR. We know that PQ and PR lies lying on the plane. So in this case, let's try to figure out what is PQ. Now PQ is the endpoint is 0, 1, 0. Alright, so it's 0, 1, 0 is Q minus the beginning point 104. So PQ in this case is minus 1, 1, minus 4, which is minus I plus J minus 4K. This is PQ. And what is PR now? PR in this case is equal to the point R is 113, endpoint. Beginning point is 104. And this will give me 1 minus 1 is 0. 1 minus 0 is 1. 3 minus 4 is minus 1. So this is 0I plus J minus K. Having known that, then I can go ahead to find a normal vector, a vector perpendicular to the plane now. So let me go to the next page. So I have PQ on the plane, PR on the plane. Therefore, if I do PQ cross PR, this will be perpendicular to both PQ and PR. Therefore, since PQ and PR lie on the plane, so PQ is perpendicular to the plane now. And this is a good candidate for the normal vector because a normal vector is a vector perpendicular to the plane. So in this case, I will do this. So PQ cos PR, let's compute this. This is equal to I, J, K, and what is PQ? Let's copy PQ from above. PQ is minus 1, 1 minus 4. Alright, so PQ we have is minus 1, 1 minus 4. So we put down PQ is minus 1, 1 minus 4. And we're going to put PR in the second row, and PR in this case is 0, 1 minus 1. So PR is 0, 1 minus 1. 0, 1 minus 1. And now we expand the 3 by 3 determinant, which will give me I times 1, 1 minus 4 minus 1 minus j times minus 1, 0 minus 4 minus 1 plus k times minus 1, 0, 1, 1. And this will give me minus 1 plus 4 is 3. So this will give me 3i here. Right? Minus 1 minus 4 is plus 3. And next one will be minus 1 times minus 1 is 1. So this is minus j. And this will be, next one will be minus k. So 3i minus j minus k is a normal to the plane. There are many normal as long as the vector is perpendicular to the plane. Alright. So this will complete the solution for question 3b part 1. Now what is the key takeaway now? So the key takeaway in this case is this. Key takeaway, what is actually a normal vector to the plane? Normal to the plane. Given you a plane, you always have a vector perpendicular to the plane. This could be upward or downwards. For example, this is called normal to the plane, and this vector is perpendicular to the plane. Alright, so normal to the plane is a vector perpendicular to the plane. And we need to compute this. There are various ways to compute this. The one I have found is find 3 points PQR on the plane, and then the cross product of PQ cross PR will be perpendicular to the plane. Alright, so for example, in the picture here, PQ cross PR will be something like this in this direction. Right? PQ cross PR will be perpendicular to the plane in this way. Alright, that will end the solution of question 3b part 1.